This is being permanently available, also highly responsive, and be sure they don't care about your server workload. So availability and horizontal scalability are two more major requirements. So on the one hand, we have clustering, which allows an almost unlimited numbers of concurrent WebSocket connections. On the other hand, we can ensure an almost 100% availability by using distributed services. Servers also have to be easily extendable to share additional services across various applications or to release the services to the public. On the other hand, some enterprises also might want to protect the intellectual properties as well as control access to proprietary applications. Since WebSockets are not subject to any particular data format, content or processing, WebSockets here mean an unrivaled flexibility. Finally, to become maintainable and accepted by the developers, the implementation of WebSockets needs to be simple. In jWebSocket we did that by providing numerous ready-to-use features and interfaces, and B, by providing it as an open source project. And that makes it transparent and comprehensible, and you can migrate to WebSockets step by step at calculable costs. So, enough theory, let's have a look behind the scenes. First of all, jWebSocket is not just a WebSocket server or a particular client-server solution, it's a framework. This means it's not about a certain product, but about a close integration of own and third-party engines and servers and various client platforms. And it's done in Java, so it can be operated on almost all server hardware. The core of jWebSocket actually is quite simple. It just provides some basic communication features like message routing, like streaming, simple send and broadcast operations, as well as an event mechanism and channels. However, the actual power of a framework is rather driven by abstraction and extensibility. Here tokens and plugins come into the game. We will show some separate slides for these. Listeners are important when you want to extend an existing application with WebSocket functionality. But of course, you also can create completely self-sufficient WebSocket applications. Filters and encryptions are the most important part of the security model in jWebSocket. But before we go into details here, let's have a look at the simple core functionality, the streams. So, I will show you a little demo of a streaming application, a very simple one. So, what I open here is a website. I connect to a WebSocket server, to the one I just explained, this $14 VMs located in Cologne. And for instance, I just register at a time stream. It's a quite simple thing, It does nothing, which is great. Let me see. 1 second. Take this one. Just 1 second, I want to show that to you. See the stream. So what we see here is a very simple stream. You just get a new event once a second, which broadcasts the current date and timestamp from the server to the client. You can register here or unregister, and this simply stops the stream. You can do that for monitoring, for instance. Yeah, you see information about our server, which amount of memory is currently usable on the disk, or how big the size is of the disk, or how many is free. So, this is about streaming. Okay. Any questions on that already? Okay. So what did we see here? We talked about the framework. The lowest components in the software stack here are the engines. They actually process the physical client connections. Of course, jWebSocket provides its own engine. This is the TCP Neo engine, just to be independent. But you also can replace it. You replace it or embed it into Jetty, Glassfish, or Netty environments. And by the way, this is completely transparent to your application. This means that changing or scaling the underlying server does not require a single code change. The streaming feature you just saw was implemented in a plugin, in a custom plugin here, like you see above. The major difference between apps and plugins is that plugins are supposed to extend the server by new common features and services, which can be shared across applications. Apps, in contrast, are rather closed solutions. To give you a first impression how easy plugins can be created and even maintained at runtime, I quickly switch to my IDE. So I have NetBeans here. So what you can see here is a token is generated with a namespace and a certain type. And you can see here, so this is the client part in JavaScript. Yeah? And you see how the client sends a token to the server. It has a on response callback, and you see a simple request response example. So you get a vendor and a version back. The server just simply answers to that request. On the server side, that looks as follows. You get a token, you check the type and the namespace, you ask for if it is my demo function, and create a response token and send it back. That easy you can answer WebSocket requests. What does that look like in practice? So, I have here my Opera browser. I log in as a simple guest. I have a listener. And currently it returns the vendor jWebSocket org version 1.0, as you can see here. Now I will change that. I will just say whatever, blah blah. And I make a version 1.1 from here. I save that, apply the changes, reopen this. I do not need to make a new connection, something like this. I just call the same function again. And you see the change already has been applied on the browser side. So the plugins are so flexible that you even can change the code at runtime. So this means if you want to extend a server for whatever purpose, or you have to update, you have to fix bugs or something like this, you simply do it and put a new plugin inside. It is reloaded at runtime, and the services are provided in the corrected or fixed way. So, let's discuss a bit about abstraction and the tokens. In the Internet Protocol stack, TCP is located 3 levels below HTTP, which is a transport layer in contrast to an application layer. This means you have a maximum level of freedom because you do not have to consider any rules for data rights processing. I just mentioned that already. And for the simple request response scenario or the streaming app we just saw, that sounds absolute sufficient. But just think of a private chat, for instance. To route messages, the server needs to understand the message, at least to identify the target. So the other side of the medal is, with WebSockets, you have to implement all the communication logic and security mechanisms yourself, which sounds kind of cumbersome for this first step. Basically, WebSocket nodes are quite stupid, and it comes even worse. In heterogeneous environments, the various clients often use different data formats. While browser apps usually prefer JSON, because it's simple, for existing Java apps, XML might be more appropriate. Maybe even you have clients that are based on CSV or whatever. The key here is abstraction. Within the server, so-called token processors convert data packets into data objects, into abstract data objects, the so-called tokens. The plugins don't know about data formats. They just process these tokens and so make their services available to all kinds of devices, irrespective of the language. And how that works, I want to show again in a little demo.